Okay, students, now we'll discuss about the experiment 9. The aim of the experiment is to determine the coefficient of viscosity of a given liquid by measuring the terminal velocity of a given spherical body. And what are the apparatus required to perform this experiment? That is a glass tube of length more than 1 meter, clamp with stand to vertically mount the tube, thermometer, lead balls or steel balls or iron balls of a different size, wet box, slide caliper and castor oil. These are the apparatus required to perform this experiment. Now we will discuss the theory of this experiment. Particularly you have to measure the terminal velocity and coefficient. What is coefficient of viscosity? To know about the coefficient of viscosity, first we have to know what is viscosity. Viscosity means the property of liquid by virtue of which an internal resistance comes into play between the liquid layers, which opposes the relative motion between its different layers. This is the viscosity. But what do you mean coefficient of viscosity? Just to know what is coefficient of viscosity, we'll explain this diagram. Suppose this is the ground, and we consider different layers of liquid. This is one layer. This is another layer of liquid. Each of area is A. Area of each surface A. Let it be at a distance of x from this, and this distance is dx. And let velocity of this liquid layer is v, and velocity of this liquid layer is v plus dv. Here, that with the increase in velocity of dv, the distance is dx, distance increasing dx, distance is dx, and velocity increases by amount of dv. Therefore, what the ratio dv by dx here? dv by dx is velocity gradient. dv by dx change in velocity divided by distance is called velocity gradient. Okay? According to Newton, there will exist a viscous force between the two layers, between the two liquid layers, which is opposite to the motion of the liquid. Therefore, according to Newton, that force, viscous force F, is directly proportional to area of the layer of the liquid. Each of area A I have taken here, and it's direct proportional to dV divided by dx. If you combine these two, then you get F proportional to A into dV divided by dx. Okay? Or F equal to, you have to multiply some constant here, that's called eta into dV by dx. But I will put here a minus sign. What does negative sign here? That velocity, here the velocity is towards right, but viscous force is opposite to the motion of the liquid. That's why I take a minus sign. Velocity and force are in opposite direction. Okay? Now, what does this proportionality constant? The proportionality constant eta denotes the coefficient of viscosity. Coefficient of viscosity, which we want to measure this coefficient of viscosity in this experiment. We measure this coefficient of viscosity. But here we can write that eta equal to F divided by E. Sorry, here I have to let A, eta A to dV by dx, A into dV by dx. This is the coefficient of viscosity. But experimentally, we measure this coefficient of viscosity by measuring the terminal velocity. Then what is terminal velocity? Now we discuss what is terminal velocity. Just to explain the terminal velocity, suppose take a beaker, take some water here. Suppose a spherical body, put a spherical body here. When spherical body is moving down, inside the liquid is moving down, then the various forces are acting on it. Weight of the body, which is exactly acting downward direction, and the viscous force F vertically upward, and another force U is vertically in upward direction. When the body moves down, a stage will come that net force on the body will be zero. That means that net downward force equal net upward force. That is F plus U equal to W. Net, the magnitude of net upward force equal to the magnitude of net downward force. Therefore, net force in this case equal to 0. When net force equal to 0, then the acceleration is 0. This when net force 0, F equal to ma. When force equal to 0, ma equal to 0. Therefore, a equal to 0. Zero acceleration means either the body is at rest or moving with uniform velocity or constant velocity. But here the body is not at rest. Rather, inside the liquid, body is not at rest. Therefore, it's moving. It's moving means it moves with a constant velocity. That constant velocity is called terminal velocity. That constant velocity is called terminal velocity. This terminal velocity we measure with the experiment. By measuring this terminal velocity, we can measure the coefficient of viscosity of the liquid. While taking this experiment, we have to take some precautions. That is, the liquid you are using in the tube that should be transparent, and balls, spherical balls, we are taking the iron balls that should be completely spherical. These are the precautions you have to take while performing these experiments. And particularly, we have to use the formula here that terminal velocity. By using this terminal velocity, V equal to 2 by 9 r square rho minus sigma into g divided by eta. This is the expression for terminal velocity, or you can say the working formula to calculate the terminal velocity by doing the terminal velocity 2 by 9, where r is the radius of the spherical body, rho is the density of the spherical body, and sigma is the density of the liquid, eta is the coefficient of viscosity of the liquid, and g the acceleration due to that. But we will find out here eta. Our m is eta, therefore eta equal to 2 by 9 r square rho minus sigma divided by v whole into g. Because our aim is to find out eta, not v. We will measure the terminal velocity. After getting the terminal velocity, you can put the value of terminal velocity here. Radius of the spherical ball, we can measure with the help of screwers, and density of rho means density of the solid body, that is spherical body, that density, and sigma is the density of the liquid through which the spherical body moves, and the acceleration due to gravity is 9.81 meter per second square. But after knowing all these values, R is made out by the screwers and other things are known things. And after measuring the terminal velocity, you can measure the coefficient of viscosity of the liquid. This is the working formula. Now, just I will explain how to calculate terminal velocity. Here only our aim to measure the terminal velocity. After measuring the terminal velocity, we can measure the coefficient of viscosity. Okay. Now, this is I want to explain how to calculate the terminal velocity by taking the observations. Now, proceed.
Now, using this apparatus, we have to find the coefficient of viscosity. Very simple experiment. Here a column of castor oil is there, and steel ball is provided. First of all, to calculate coefficient of viscosity, we have to find first of all we find the density of steel ball.
Density of steel ball. So usually in a steel or iron ball, I think the density is 7.8 gram per centimeter.
Then a known volume of castor oil was taken, whose mass was measured, and that was calculated to be 0.9 gram per cubic centimeter.
Sigma is the density of castor oil, that is 0.9 gram per centimeter. That means rho is over density over g already known at 9.81 meter per second
We
square.
have to find out radius.
Radius of the spherical ball.
Radius of the ball, as it is explained earlier, we can use as screws to find the radius. So using the screw first, here I have taken the application. एक it comes around 0.307 centimeter.
How much coming? I have
Using screws, ICSR
What are the radius
comes
of
to be ICSR comes to be 92. Then after that, number of complete rotations 3. Then finally it stops at 80 height. So difference comes to 7 and T is getting 0.3. So total diameter comes to be 0.307 centimeter. As it is explained earlier, you will use screws and find the diameter.
diameter, then they can
And
find out
calculate the
radius. That means all
radius
these
0.307 divided by 2 comes to be the radius. Only we have to find out here terminal velocity.
terminal velocity.
So for that, we will drop steel balls. Here, marks are given at regular intervals are around. Okay. Position of 40. Here, that is zoomed over the cylinder at position 40, then at 60, then at 80. That means at a difference of 20, there are 3 marks. And we assume after passing through a column of cast iron, the steel ball will attain terminal velocity. We will use stopwatch. We will start the stopwatch when it crosses the point, say A here. Then we will stop one stopwatch at point B, the other one will be stopped at point C. So we will measure the distance covered, that is total 40 centimeter, and we will measure the time by the stopwatch. How much time is taken to cover total 40 centimeter, and how much time is taken by another stopwatch by covering a distance of 20 centimeter. For both cases, you will find the velocity, distance covered by time taken, and we will find the average. That will give us the terminal velocity. So at a time, we have to use both the stopwatches when it crosses the point A, and we will stop one stopwatch at point B, the other one will be stopped at point C, so that we will measure the time. That means, and we assume after passing through certain distance, the ball attains terminal velocity. The velocity becomes uniform. So for doing that, now in one it comes to be 5 seconds for covering a distance of 20 centimeter. 20 centimeter is covered in 5 seconds, and in the other one, total distance of 40 centimeter is covered in 10 seconds. 10 seconds. So for both the cases, in one case, the distance covered for unit time, that is 4 centimeter per second. In the second case also, it comes to be 4 centimeter per second.
In both the observation, it's coming. The distance 20 centimeter distance, time taken is 5 seconds, and 40 centimeter distance, time is taken 10 seconds. Therefore, speed equal to distance covered by time. The first is equal 20 by 5 equal to 4 centimeter per second. In the second case, it is also coming.
4 centimeter.
That is 40 divided by 10 equal to 4 centimeter per second. That means the velocity is coming constant. This is the terminal velocity, 4 centimeter per second. Now we can use this 4 centimeter per second velocity in this formula. Other things already we have calculated. After calculating the terminal velocity, then we can calculate the coefficient of viscosity. And here you are using all of the CGS system. Finally, that your coefficient of viscosity will come in the CGS unit, that is COH. After putting all the values, you get the coefficient of viscosity in the unit of CGS unit.